Hello, Drew. Hello, Suku. Can everybody hear my voice?
Good morning. I was having trouble. I had a bad audio setting. Sorry. I can hear you now. Uh,
Yeah.
good morning.
Hi, Drew. Hi, Ryan. Yes.
How are you all doing?
Hi, Drew. It's good. I'm currently
Fine,
uh,
thanks.
on the business trip to South Korea.
Oh, wow.
Uh,
Um, that's on my bucket list. Maybe not a business trip to South Korea, but a trip to South Korea. I would love to visit.
oh, yeah. It's good. Good place to visit.
It looks like it.
Yeah.
Mm-hmm.
Yeah. Oh, absolutely. I was also there uh, previously, so yeah, it's lovely.
Mm-hmm.
Yeah, we've watched a bunch of Korean TV shows, so um, we joke we want to visit Jeju Island and see the site of all the disasters because in a lot of the TV shows, something bad happens on Jeju Island.
Oh,
Mhm.
It's kind of like the Golden Gate Bridge, right? In all these sci-fi movies, the Golden Gate Bridge gets, or San Francisco gets attacked. But there are a lot of nice
I'm,
things in North Korea, in South Korea that we would like to, we've seen and looks beautiful.
yes. It's a very good place.
We'll wait for people to join.
Mm-hmm. Actually, for today, I have a plan to present the JEDEC proposal our side, the summary, but unfortunately, we are the SK Hynix SK Hynix internally doesn't reach the full agreement about my proposal. So I will briefly touch those items first, um, and probably within a month we can reach the final agreement internally, and then I can show you again about our direction to the JADAC proposal for the LPDDR features.
Okay, that sounds great. And then I've been
Anyway, oh yeah, go ahead.
I've been talking to Adam, and Adam has a draft of a proposal uh,
Oh, yeah.
from Microsoft side, but we're not quite ready either. So uh, but we're working on it. So I'll look at yours and I'm going to try to or whatever you can share, and then um, we'll. I'm working on another one, and I'll try to get it ready to present as well. It's also taking a little bit of time.
Mm-hmm. Okay.
But I think our goal is, similar in that we want more data more often. So, uh,
Mm-hmm.
just what that data is will be, we'll just have to discuss.
Okay.
So, did you have something that you could share today, or is it
Oh, it's about the discussion format. So I can share something, some files for today.
sounds good?
basically, as I have said before, our proposal is the how to summarize the DRAM fault internally, and then how to transmit those data to the host side and how to utilize those data. For the but very the detailed implementation must be considered and checked inside with the DRAM designing team, um, would be finalized after review the very the details. Anyway, the discussion direction would be similar. That we want to summarize the DRAM fault and error logs on the DRAM devices and the memory controller side, and then summarized data. Uh, we believe it is efficient. It is more efficient than the raw data.
Hmm. Okay, and that's consistent with what we've talked about in previous discussions, right?
Yeah, right, right.
So, oh, and I see some other folks have joined. So, Adam, I'm really glad you're able to join. We're just talking about SK Hynix's proposal for improving, ECS and error logging, and I would mention that you and I are working on something as well.
Yes, yeah. So I'm very interested to hear about this summary idea rather than raw data. Yeah, yeah. Good.
But what I found during the discussion with our end customers, the SK Hynix's DRAM fault is unique for the SK Hynix only, and that means the different supplier shows the different main fault DRAM fault mode and something. So for example, our SK Hynix DRAM devices, the row type fault is the main category of the DRAM fault classification, but other vendors uses different method. So we have to contain those variation in the data specification. So uh, that's the one key thing we have to consider.
Well, and that's for taking actions, right? And so
Mm.
like for doing a row repair, right? So we can drive a row repair quickly.
Mhm.
And then do you have a thought on how we would do kind of fleet analysis of DRAM with you with that proposal? Or do we need to have a separate proposal to figure out how to get enough detail to look at the health of DRAM at Fleetscale?
I think this proposal doesn't require the separate analysis framework. It is a kind of it can be involved in the current analysis method.
Okay. So like if we had a pattern of failures, something like a bit line that works less effectively the further you are away from the bit line driver. I guess we could
Mhm.
tell that because we could tell which rows were having more errors. So if we had a word line that was getting weak, we couldn't really tell because the we don't know which bits were flipped.
Mhm.
So we can't really we don't have quite as good a visibility as we did in DDR4.
Right, right.
So that
That's the,
so can we find some middle ground where we have a little bit better visibility? Maybe we don't get the precise errors, but could I have some data about where on the word line the error was?
mhm.
Anyway,
Yeah, that's a quite tough problem to solve.
okay.
Yeah, and Roy, if I could ask a question, when you said that SK Hynix is unique, does that mean that um, any solution or that the solution you're proposing is only applicable to Hynix and wouldn't be applicable to other implementations?
I'm not sure at this moment, but uh, as long as I know, our DRAM fault classification is rely on the DRAM architectural hierarchy. I believe that across the DRAM vendors, basically the DRAM architecture is very similar from each other. So the classification can be applied across the vendors. But the problem is the the percent distribution of or the Pareto distribution of each DRAM fault could be different. So depending on the DRAM vendors or design style, and design style, the, each DRAM vendors have to provide their own fault modes and summarizing method through this framework. Uh,
Okay, thank you. That makes sense. Thank you.
yeah. Still, I'm curious about the why the DRAM vendors, each DRAM vendor shows the different distribution of the fault. Uh, so that's that is a very interesting question we are currently confronting. So can I briefly present my material first?
That was what we had scheduled today, so that
Uh,
sounds
it's,
good.
yeah, this presentation material doesn't include the details, but based on this description, that we are currently uh, discussing with internal team, the DRAM designing team and product planning team in SK Hynix. SK Hynix. So with the name of the framework for enhancing the raw section accuracy and efficiency. Here the accuracy means the accuracy means that the recall and precision, and efficiency means when you see the DRAM error logs, which was collected by the DDR4 and DDR5 system, in some cases there is a redundant DRAM logs, or in some cases there is a insufficient DRAM logs. Probably those redundant or insufficient information would be larger in the case of the HBM and LPDDR system because of the lack of the correction capability and sampling frequency. Yep. So the motivation and objective is pretty obvious. So our proposal, we are currently aims to improve the accuracy of memory raw section and the efficiency of error handling and system response and actionability to error telemetry by introducing a standard and structured framework. So as I have said, probably their structured and standardized framework or data set can be different from depending on the DRAM vendors or design style of each devices. So scope of proposal would be the summarization of error information and transmission method, and also we want to include how can we utilize those data at the decision making and taking action. A summarization of the error information is so clear. The raw error logs are often too large or redundant to be efficiently utilized. Therefore, we propose a standardized summarization method that capture and here is the what we want to do. The essential statistical features or of error behavior must be captured, and those should be uh, summarized. For example, the spatial locality. Spatial locality means if errors are localized with the theorem hierarchy for some level of theorem hierarchy, such as the subordinate driver or multiple or every other subordinate driver, then those information must be summarized and transferred. And also, if the temporal clustering, if the error counts per unit uh, time interval, the error count is abruptly increased, then those ones should be notified to the host side. The reason why we are introducing these features is the first error log detector would be the in-RAM ECC, not the host level ECC. So the in-RAM ECC's error count could be the good source of the error clustering or temporal clustering. And also we want to share the recurrence pattern. And the one thing we have mentioned before is if we see the error logs of the subordinate word line level fault, it has a pattern which is aligned with their higher designing style, and those recurrence pattern or distribution pattern should be uh, transferred to the host side to be utilized well to prevent the future uncorrectable errors. And the second thing we have to consider is they reduce the data volume while preserving information relevant to the memory cross-section decision. They, they, we are currently researching uh, focusing on how to preserve information amount without loss of with the small amount of the error data. So we think the preserving the information amount is the key things when we are considering the summarization. The third one is to enable the consistent interpretation across the vendors and platform. And so the SK Hynix would definitely provide all the detailed information regarding our DRAM fault in the future. So every summarized data with the interpretation of those data that we will provide. And probably this one is not the specification one, but those interpretation or information must be supplied. And here is some example. The number of distinct faulty column address per address region is very important because these information shows how the data fault are distributed inside of the bank or across the bank. And the second one is the fault rate of temporal fault rate of the different errors. And the third one is this information should be classified with the physical channel, die, and what line, or blah, blah, blah. And with the detailed information of each cases of our DRAM fault, after we discussing internally which and reaching their agreement internal designing team, then I can share those information again later.
Roy, is this
Yeah.
summarization specifically for in DRAM ECC, or is this, I mean, like, I'm just trying to orient
Oh,
myself
yeah.
a little.
Oh, yeah, that's a good question. We are currently focusing on the Indram ECC first, and then I think this kind of the summarizing method could be applied on the memory controller side ECC also, because in some cases the LPDDR devices, uh, depending on some associate partner or end customer want to use the interim SSC turning off, then the information would be more information would be collected by the memory controller side also. So we are currently focusing on the interim SSC at this moment, but the concept could be applied memory controller side also.
Okay, thanks.
Mhm. Transmission of error information is another key features. So the efficient and scalable transmission of the summarized error data is critical because the one of the key things we have been considering is when we are trying to deliver the raw data, then the bandwidth to deliver or transmit those raw data would impact uh, the impact on the bandwidth would be very high. So the more efficient and squeezed information and structured one would be we believe that it would be more efficient than the raw data. We propose the standardized telemetry format for summarized error information. So currently we are discussing how to standardize the telemetry format, which was summarized by the Interim SSC first, and then probably we can share some example of this one. And the second one is hierarchical reporting. That must be supplied, needless to say. And third one is the mechanism to balance the bandwidth overhead and information fidelity is basically uh, has some trade-off. So the so we have to we this make the decision for how to summarize the information and then we'll calculate the bandwidth impact or overhead of those information transfer.
And Roy, just this resonates with me, especially the hierarchical reporting. And I
Mm-hmm.
just wonder, like if we could do something as a team or across the industry to to put things in memory controllers that do a better job of
Oh.
coordinating work with the DRAM to get the error information. So, we're not waiting 24 hours or, maybe like on a HBM, if you see if you see a 7-pin asserted, we could create a standard for checking that row for for a repeated error, or we could if we can define work that the memory controller does in coordination with the correction inside the part, maybe we can do
Mm-hmm.
a better job of diagnosing problems.
Mm-hmm. Oh, sounds great. So uh, yeah, it sounds great. We are very open to collaborate those features with the current memory controller and SoC side.
Okay, that sounds really interesting to me, and
Oh yeah.
it kind of ties in with what do we want to log for DDR because we have a DDR5 logging document, right? We from this group, and so what do we want to log from DDR 5 and 6 and HBM and LP, but then like in addition to that logging, it may be that we need the memory controller to react a certain way, and
Mm-hmm.
and I think we could work through that a little bit, and
Okay. Okay.
some common things that would help. So I'm just throwing that out as a thought because I think that hierarchical reporting, as you've described it, will require some coordination across
All right. Right.
the device ranking system.
Oh, sounds great. I think those collaboration must be we must collaborate
Yeah,
together
we
regarding
can't.
this one. Actually, we are not familiar with which hierarchical definition is more good to manipulate this data.
Sounds good.
Okay. Oh, during you are mentioning there, I found that there's 24 hour scrubbing period doesn't give us good information especially for the LPDDR and HBM devices. So we basically want the event-driven scrubbing, event-driven interface for the error information transfer.
Yes, please.
Yep. So in this case, when you see the abnormal increase of the DRAM error rate, which is detected by the interim SSC, or the specific DRAM fault error pattern were detected by the interim SSC, then it should be notified to the host side to gather or to get the information which was collected by the interim SSC as soon as possible. And we have to define what I'm saying is we have to define how to notify to the host to get those information which was summarized by the DRAM devices. So we basically want to enable the event-driven error log or information transfer. So I totally agree that 24 hours scrubbing period or regular reporting method shows the clear limitation when you think about the actual DRAM error behavior. Okay, anyway, for the error information transfer, the backward compatibility must be considered first. So for the case of the DDR6 or DDR5, we have an alert pin which can be utilized as a notification method to the host side by the DRAM. And also the MRS read operation, MRR or MRR could be utilized to get those information from the DRAM devices. And reporting granularity, it should be structured with the hierarchically. So the interbank for the interbank fault or intrabank fault, and also the device level fault should be reported with some structured manner. And third one is the event-driven one. Unfortunately, current error log collection is basically periodic, rely on the periodic reporting, but we believe that it's not the good feature for the future devices.
So I'm sorry, you're saying like no periodic would make it all event driven?
No. The 24 hour scrubbing or periodic could be implemented also, but we are focusing on the event. On top of that, we are focusing on the event-driven one.
Okay,
Yeah.
makes sense.
Periodic reporting method would be included. It's a good feature, actually.
Yeah.
So would the information in those registers be generally always available so that if they were doing something periodic, you could continue to read them, or only generated in response to the actual events?
Pardon me. What is I?
I guess I'm wondering then, so keeping both methods, any of the information that's theoretically added to the new reporting once the extended sets of information, they would be generally available anytime you wanted to try to read them, right? Or in this like
Mhm.
event-driven mode, would it be only like generated in those registers in response to the DRAM deciding that it's detected events or that the particular period triggered?
Uh, but it depends on the implementation. So, but currently we are thinking the separate register set for the event-driven one and the periodic reporting one.
That makes
Okay.
sense.
Yeah. Actually, the register set for for storing temporary those information is not so big. Big is the size of those register set is not so hurdle, not the hurdle for the DRAM designing. So we want to implement separately. Okay, regarding the error data analysis, actually this one is the kind of the OCP FM work. So uh, we basically provide all the information regarding the DRAM devices fault, uh, and those faults should be verified during the system build stage. So the one of the bad memory in my mind is when you found the first type of DRAM fault during the build operation, then we have no choice to apply the new last features, even though the hardware was already uh, hardware or equipment was already implemented, uh, except the verification was not completed during the system build, so we cannot apply the new features or new ROS features to enhance or solve the current problem. That's why we are focusing on the data analysis method during the verification and validation stage. So we will define the common interpretation guideline for summarized data and enabling the identification of the degrading components, systematic fault patterns, and early warning.
Okay.
Early warning, blah blah blah.
Yeah.
Anyway, this one is just the add-on summary of this uh, proposal. But the details of this proposal would be added, and before we are showing at the JEDEC meeting, I will share with you in this discussion first. Yep,
This
that's.
sounds really interesting, and I think, Roy, the really critical thing to me is that we connect the data that you're talking about here with
Mhm,
the analysis framework we've been talking about in the requirements document, and
mhm,
we make it so that we can capture this data at scale. We can
mhm,
fix individual machines, but then we can also share the data with you and improve overall memory reliability. So,
mhm,
but I think what you're proposing is along those lines. And then I think the question that we're going to debate is, what do these summaries look like and how detailed do they need to
mhm.
And so that'll be, I think where we need to have the discussion. But when you've got your proposal, we can do that. And then Adam and I are also working on a proposal. And maybe we can, compare them and try to find a good answer together. And Adam, I'm not trying to speak for you, but I think that's consistent with what you and I have been talking about.
Absolutely. Yep. Completely agree. Roy, I did have one question. Earlier, you talked about, your SK Hynix would share, or could share fault bounding details. But is that necessary for this proposal? Because if you're summarizing the data and it's in a standardized format, do SoC partners or end users still need the detailed
That,
fault boundary?
no. The detailed fault boundary would be different depending on their vendor or design styles. So those contents would not included in the specification. But when the end user or SoC partner is developing their formula code or system validation method, our information regarding our known DRAM fault would be fully provided to enable in the system at the end user level.
Okay, for known faults. Okay.
Yeah,
Yep.
about the
Okay.
known, definitely.
Okay. All right. Great. That makes sense. I was just wondering if understanding was needed to enable the summary proposal, but I get it. It's for aiding system debug validation. Yeah, publishing known failure mechanisms.
Mm-hmm.
Okay. Thanks.
Yeah. Okay, that's it for my presentation for today.
Yeah, and I just got a message from Drew that he lost internet. So he's having trouble reconnecting, but I believe that was all the material for today. So.
Yeah, I can share for today's material.
Okay. Yes, I know others would be interested. I'd certainly be interested to have that. So, and look forward to further discussion. I guess last question, Roy. What is your timeline to present here and then at JEDEC?
Oh yeah, actually, as you might know, to propose the JEDEC, we have to consider all cases of the implementation-wise first internally. So it would take 1 or 2 months. So after 1 or 2 months, we can share the final proposal.
Okay. Yeah, that sounds like a reasonable timeline. Sounds great.
Mm-hmm.
Okay. Yeah, I don't know if we're gonna get Drew back. So if there's no other questions, no other discussion, we can close for today.
Okay. Okay. Thank you, everyone.
Thanks.
Yeah,
Bye.
thanks all. Thank you, Roy. Thank you.
Thanks.
Thank you.
Bye.
Thank you. Bye.